with a big round of applause.
Hey, I guess that means the microphone's on. Hi, everybody. Nice to meet you. Good afternoon.
여러분 안녕하십니까? 반갑습니다.
My name's Thomas Winkley. I work for Unity Technologies as a technical marketing advocate. So this talk is called Creating Interactive Worlds with Unity, and I thought it would be cool, since this is a Metaverse conference, to talk about all the things you can build in relation to the Metaverse using Unity. So to get started, let's jump in and we can talk about who I am a little bit. So like I said, I'm a technical marketing advocate. I'm based in Salt Lake City, Utah, which is on the west coast of the US. And I do a lot of rapid prototyping. I do a lot of teaching of gameplay programming and code. My favorite genre of games is fighting games. And the best food ever made is pizza. So I thought I'd share that with y'all before we get started. So safe to say, especially being so late in the day, you've all probably had a pretty broad perspective and been given and shown what the Metaverse is, right? You have an idea of what this is. And so really, I want to focus this talk on the massive ecosystem of tools that Unity has to help you bring your ideas into the world of interactive and real-time content. In the small chance that you don't know much about Unity, we're the world's leading platform for creating and growing interactive real-time 3D content. We have our core editor and a bunch of different available packages and other tools. You can use what we have to create a ton of different experiences and other pieces of the metaverse as you see fit. Anything from interactive worlds that you may go and meet other people in, to educational experiences or anything along those lines can all be built and crafted using an engine like Unity. So one question I get quite a lot is, well, it's a game engine, right? So what can a game engine do for me in something like this? And something I like to try to change minds towards is it's more than a game engine. It's a real-time 3D platform. And so what that means is that it can create real-time 3D experiences. So while games are what we're built in, games are the core and the starting point for us, it really goes beyond that to allow you to do things like simulate real-world
실제 생활을 시뮬레이션 할 수 있다는 것을 말하죠. 이 산업이 계속해서 특히 자동차 산업
as they start kind of going, they're gonna see new competitive advantages, and a lot of that, in order to get there, they're embracing interactive and immersive 3D experiences. What we're seeing here is actually a configurator that we built for Timmy, and this is really powerful because you can see the actual exploded view of all the pieces, and inside this experience, you can dive in and look at all the parts, the part numbers. So if something goes wrong with this, you're able to look and see what's broken and then go forward and fix it. So the way I like to break this down is that if we can simulate this for a game, then we can simulate it for the real world. So this is impacting so many more things than gaming, right? It's going to tackle medicine, training, architecture, engineering, construction, manufacturing, and film. Really, the sky is the limit when you start thinking about all the different things you can do using a real-time engine and creating simulations. So the thing I love to call and to talk about when we do these types of things are digital twins. So digital twins are powered by real-time 3D engines, and they allow us to recreate the world as we see it and test theories. There's different pieces of placement of where things could be. If we're testing a new car, if we're testing construction equipment, or even a 2D or 3D recreation of an airport, for example, or a new retail space that we're going to be building, we can create a digital twin of it and experiment with it before we actually physically build the thing we're thinking of. So using digital twins, companies are transforming the way they work, and this is affecting them in their design processes, their engineering processes, their manufacturing, their sales, and their service. And there's so many different applications to how these work that once you create something, you can quickly iterate upon it. You can change it, you can modify it as you get your data back. And the world really starts to open up to you. So these are things that I would like to really, really bring into perspective, because digital twins, being a replication of a process or an object or a thing, give you the ability to build and create faster, and they're changing a lot of things we do. So now that I've kind of given a few minutes description of digital twins and how they work, I want to jump into some of the tools that are used to create these types of experiences. Or, as we like to call it, the tools for the metaverse. So one of the things you're going to see is, to create real-time content, there's a lot of tools out there outside of Unity you need to create things, right? So if you're creating something like a 3D asset, as an example, you're going to use tools like Blender, Maya, ZBrush. We call them digital content creation tools, or DCCs. And they think a little bit differently than a lot of the things being used to create automotive manufacturing and engineering pieces. Tools like Rhino, Fusion 360, Revit, CATIA, Navisworks, and a bunch of others. They don't think about geometry or the shapes you're putting into your engine the same way that a tool like a game development tool would think, right? With game development, we have to think about a lot of things like optimization, how many polygons are we facing, what are our edges like, that type of stuff. But when you're building something for manufacturing and engineering, you want it to be as accurate and perfectly replicated as possible, and you want to include a lot of data, including metadata and information about all the parts, pieces. This can be anything from exactly the color of paint that goes on a metallic surface to the part number and where you order that part from, all of those things. And so as part of that, we've built a connection to help bring a lot of that data in to help you move your digital twins faster. And this is called the Pixies plugin. So Pixies is an integration piece in Unity that lets you start bringing in these different types of manufacturing file types. And it imports, you import most industry-leading solutions and standards and formats and the metadata associated with them. So instead of having to take your model from one of these tools and then recreate it in another tool and then put it into Unity, you can scrub that process out completely, and you can actually just take it and import it directly and start working with it. It's also nice because it lets you create ready-to-use assets, and you can tessellate meshes and deconstruct them a little bit to get your optimized polygon counts. You can also automate the tasks and the import tasks using rules. And it has an extensible C# API, so you can actually write your own code on top of it to help enhance and modify your processes as you go. And I like the way this image kind of shows the way this is set up, because if you look at the steering wheel, you can see how clean the geometry is wrapping around here and all these different faces. And that's all been put through Pixies and processed to make sure it's nice and optimal to be inside of a real-time 3D engine. If for some reason you're working on a digital twin style process for something and you actually want to take it beyond doing something just inside the editor and you want more customization, then you can actually step yourself up and use Pixies Studio. So Pixies Studio lets you do the same thing, but it's actually its own software that you can then build and then repurpose to move into Unity. So this has, of course, all the CAD format compatibility that we talked with. It has a native hierarchy, so you can actually go in and edit the hierarchy of your object and all the different parts. A really good example of this is when you model, say, a jet engine, that model inside of one of these CAD tools is going to contain all of the individual screws and pieces, right, that assemble it and put it together, because those are all really important parts of the data. And you can take them into Pixies, and depending on how you want to utilize them, if your model needs to have every single bolt, every single screw, every single plate, and where that plate comes from, you can leave it that way. But if you're doing maybe a demo where it's being driven around and you're not doing repair work, you could actually tighten up and clean that hierarchy up and merge those objects together so that you don't have to have as many individual moving parts. It's powered by a native hierarchy, powerful algorithms. You can, of course, automate tasks and import metrics there as well. This is really powerful when you're trying to automate and clean up your workflows, right? If you have a certain process that works for the products you're building, you can set those rules and have them be part of your custom import so you don't have to redo those processes and rules consistently. It also allows you to scale your data preparation and really focus on building all of those different pieces as you see fit. So once you've converted a lot of that data for your digital twin, and this is just one form of digital twins, I want to be really clear on that. I talk quite a lot about this Mainly because I like to see things. Let me jump back to this slide really quick. This is just one piece of the puzzle of digital twins, right? And we see the automotive example here. We see this beautiful retail space that's been twinned. And the powerful image of these things is however you want to visualize this data, you can do so. And our engines give you the power to do that. Something I like to say when I'm speaking to students quite a bit, which I get to do with my job quite a lot, is if I can put like a Pokemon on a table, like in the example of Pokemon Go, that also means I can put a building on a skyline using my phone, right? Augmented reality performs similarly. So if I'm going out to build a building and I want to see what it's going to look like in these areas I'm building in, maybe it's being built down the street from my house and I would like to see what it would look like, I can actually just point my phone at the skyline and impose the object there to see what's going to happen before we actually start construction, right? Saving time and money. If anything's ever wrong or incorrect, we can test it. This image right here is something you can find on our use cases. So this is actually a 2D digital twin of the Vancouver airport. And what's cool about this is they built this digital twin to work with the flow of people and speed and see if things change at different times of day, how that's going to impose on the traffic speed of users as they go through this airport. And if they move different railings, different ramps, they put out different signs, how that will impact those flows. And it was so successful that they're looking now and moving forward into building like a 3D version where they can actually start worrying about fleet management, air traffic, and that type of thing as well. So there's a myriad different types of digital twins you can build. For the specifics of talking about some of these tools you can use from us, I just like to talk about the manufacturing side. Of course, medical training, you see them wearing the basically look. I'm not sure which headset they're wearing there. But again, they're using that to experience medical training, which is a lot better way to put people into high pressure situations with something like this than it is if you were to imagine actually making them experience those traumatic situations. Okay, cool. So I just wanted to jump back and cover some of that. So let's see where we were at. Let's jump back one more. So once you've done and worked through all those tools, the thing that you have to consider is the editor itself, right? That is the base of what we do. Like we said earlier, this is like a real-time 3D platform. We're considered one of the world's leading development platforms for this, and this allows you to create amazing games and experience across the widest range of platforms. So this is something that we really pride ourselves in, is when you build something in Unity, the ability to deploy it to multiple things is there. So if you build an experience for one type of VR headset, you can then use other tools to take those things and convert it to deploy to another headset. And you may have to make some changes to it, maybe in some of the interactions or some of the code, but you don't have to completely rewrite the application, which speeds up your iteration time and your deployment time. So the next thing I like to talk about, and I like to talk about it because I hope to one day be a really, really talented technical artist. Right now, really good at programming. This type of stuff I'm not as good at yet. But shader graph is super important in any of these artistic creation pieces, whether you're creating some kind of a metaverse world where people are interacting together, playing games together, or if it's recreating a digital twin of an object. This allows you to have fast iteration time at every step of your shader creation process, and you're not worrying about writing actual code syntax and then recompiling. Instead, it's all a graph-based system, and this mirrors a lot of industry workflows that you're going to see in a ton of other art tools. You simply connect all your nodes to a graph and drive your creative vision, and you'll notice in this image, you can see that all of these different changes as it goes through the different pieces of the shader iteration are actually, for the most part, being previewed, so you can see what the changes are going to look like in real time as you iterate and tweak your values to make these shaders look a lot more powerful. So these are a great amount of shaders that you can look at that were created with Shader Graph. I think my personal favorite out of this kind of slice of images is this middle one with the water with these gorgeous reflections bouncing off. The raindrops are actually really, really powerful and cool as well, as you see those ripple effects kind of coming out. And all of that is being done utilizing Shader Graph to create these beautiful dynamic worlds from a myriad of environments. So I've talked a lot about some stuff, but I want to share something that I find to be really important. A recent integration to Unity is visual scripting. And this allows anybody using Unity to create scripting logic that would normally be written in C# with a text-based coding language with visual drag and drop graphs. And the reason I love to talk about this anytime I do a presentation, anytime I get a chance, is that you can actually write C# scripts or use visual scripting, and the two can work together. So somebody like myself who is a programmer can write a lot of code, but then somebody who may prefer to use visual scripting can also design and build out their systems, and we can communicate among each other to make sure things are getting built correctly. And I love to talk about this because when we were building our mobile AR development pathway for Unity Learn, which I'll talk about here in a minute, we interviewed a ton of XR creators. And even though they were doing something that a lot of us consider to be highly technical, creating a mixed reality, right? Creating virtual reality, augmented reality, they didn't consider themselves as technical because they weren't writing code. They were using a visual coding solution. And so I like to talk about this to let folks know if you are using a visual coding solution, just because you're not writing text-based code, you are still coding and you are still being very technical. And it's a really valid way to create, because one of the things that Unity we want to do is we want to get this technology in the hands of everybody, regardless of how you want to engage with it. So if you want to be a programmer like me, you can absolutely do that. But if you want to create something without writing any code, you should have that ability as well. And visual scripting is one step towards helping you do that, as well as a lot of other pre-configured components that I'll also talk about as I kind of go through some of the things we have. So I think that covers all the stuff about visual scripting. I told you it was really cool, and that's the most important part. Visual scripting is something absolutely amazing, and I'll talk about some content on like Learn if that's something you're interested in diving into. Another thing that I find to be really powerful in Unity and creating this any kind of experience, whether Metaverse or not, is a scriptable render pipeline. And the scriptable render pipeline, it allows you to control the rendering of your objects via C# scripts and assets. And this is a really cool technology that underpins our two main rendering pipelines, the universal render pipeline and the high definition render pipeline. And you see these images down here, they're actually examples of the two pieces. So you can see this left with the water and the bridges is actually done with the universal render pipeline. And this one on the right is a shot from The Heretic, which is one of our short films you can watch on Unity's YouTube, that is done with the high definition render pipeline. And we can talk about kind of what those are now. So the universal render pipeline is a pre-built scriptable render pipeline made by Unity. It provides a very artist-friendly workflow that lets you quickly and easily create optimized graphics across a range of platforms. So this is really the render pipeline if you want to deploy across the widest range of devices, because you can set up your optimization through assets really easily and use those to deploy to a bunch of different things. So a great example for that is I might be deploying to my phone here, which is a couple years old, and I might also be deploying to my wife's Android phone, which she's only had for 6 months. It's brand new. And so her phone is actually more powerful than mine because it's newer. It has better technology. So when I go to deploy this application and I want to target a 4-year-old device like mine, I can adjust how the universal render pipeline handles lighting and handles shading and handles shadows and all that stuff so that it will still run fluidly and be playable on my older phone. But then I can change a new profile to go a little more intense, a little more high end to run on newer phones as well, so they get a better experience on their better hardware because it can handle it. And it's not something that I have to spend a ton of time writing special rendering pipelines or anything like that. I, of course, could use a scriptable render pipeline to write my own rendering outputs, but I can use a universal render pipeline to set up all of these different optimization outputs to make it run better on different devices. So the high definition render pipeline is another pre-built scriptable render pipeline built by us that lets you create cutting edge, high fidelity graphics for high-end platforms. So this is your AAA rendering engine to build the best looking stuff you can build. This is if you want to target next-gen consoles, high-end PCs, high-end VR headsets with a lot of processing power, or a headset that's tethered to a PC that's going to have that processing power backing it. It allows you to create these really beautiful and powerful experiences. And again, you're using things like volumetric lighting, volumetric fog, rendering volumes, all kinds of stuff, and you don't have to write the code for them yourself. You can build these objects out and put them into play pretty easily. So The next thing I like to talk about in these types of things, after rambling about rendering pipelines quite a bit, is that the XR interaction toolkit, because this is another important piece of building out the metaverse that we provide, that allows you to create things with or without code. So the XR interaction toolkit is a high-level component-based interaction system that lets you create VR and AR experiences and provides a framework, and it sits on top of the open XR standards, which means it's also deployable to a myriad of devices. But it's really powerful because it allows you to have all of the things you would want in, say, like a virtual reality experience without having to rewrite all the things that have already been created. I love this because it provides snap turning, where you can actually flip the controller and snap your user's movement like this very quickly. It has ray targeting, it has pickup interactions, it has sockets, and all kinds of other things that you can just utilize as a component-based system. And then if you find you need to do more with it, you want to go further, you can of course extend it and change it using C# and other code options. Well, no, really just C#. So you can take C#, dive in, change it up, extend it, modify it to fit your needs if the base implementation isn't doing what you would like it to do. But I've used it for about 2 years now, and it gets better every year. It's constantly being updated, constantly being changed, and of course, making its way forward with new versions of Unity as well. The next thing I like to discuss when you're talking, metaverse type content is AR Foundation. So this is our similar extension for AR that sits on top of Google's AR solutions and Apple's AR solutions that allows you to create these AR experiences and again, deploy them to multiple devices without changing a ton of code. So if you want to do, for example, surface detection, which you see right here happening with this little plane here, you can do that. And then when you go to deploy it to the device, AR Foundation already has the implementation, and it's simply going to tell you, hey, this is how or this is where I connect, and then I will build to iOS, to Android, or to whichever other operating system. I guess those are really kind of the two main mobile operating systems, but it also allows you to object placement, hand tracking. It does now, it actually tracks people in shots now. It can do facial targeting, and a lot of other pieces there that allow you to, again, not have to rewrite the solution, not have to build it again, but instead focus on building your incredible solution using these tools as part of what you're building. So I just kind of talked to you for 25 minutes about a lot of tools that you can use within Unity. And full disclosure, this is only a few of them. There are tons available to you, and there's also tons of stuff in the asset store that have been built by incredible creators. But if this is something you're thinking, I would love to learn what this is, how it works, then check out learn.unity.com. This is our free Learn platform. It's on-demand learning content built internally by Unity. We have a full real-time team that sits on the social impact team that I'm on. They're incredible. They're awesome developers, and they help build out all of this content. It has 3,400 plus tutorials. It has 600 projects and courses, so over 1,400 hours of content, and it all builds and focuses around all of these types of tools that we're looking at right now. And something I like to show when I'm talking about these types of things, hopefully my screen share lets me transition really quick when it loads, is Unity Learn here. And we can look at our pathways. And I like to show off our learning pathways the most because these are actually built to help you get the skills you want towards those types of things. So Unity, if you've never done any type of development like this before, then Unity Essentials is where you start. It talks about the industry, how real-time 3D platforms think, and it actually has you publish your first small app right here. If C# and coding is the way you want to go, we have the junior programmer pathway that lets you dive in and learn a bunch of different coding ideas. By the end of the pathway, I think you've built like 8 or 9 different prototypes. You've also built personal projects to help enhance your portfolio. I actually reference junior programmer quite a bit when I'm not sure how to do a specific thing. If I can't Google it quickly, I will jump on Learn and check that first when I'm working on a project because it has so much information packed in there. And that's actually something we commonly refer a lot of our customers to if they're stuck. Of like, hey, here's a tutorial that'll help you fix this. A lot of that lives inside here. Creative Core is going to cover a lot of different aspects of everything that's not code in Unity. So this is going to dive deep into audio, lighting, materials, all of the stuff you need to make your project look, sound, and feel good without the coding portion of it. So more on the art-focused tools, I guess is the way to describe that there. And then the other two that are the newest and near and dear to my heart, because they were a lot of labor from our instructional team, is VR development and mobile AR development. And I really love to point out the VR development because it actually shows you how to use the XR Interaction Toolkit to build out your project. It's also really cool because it focuses on industry broad stuff. So while you're working on a small game as part of the tutorial, you're actually building an architectural rendering as one of your projects outside of that. And it's like a small apartment space in a city that you can walk around in. So it actually shows you how you would apply these tools in a industry outside of just gaming. But again, the beauty of all of this is it's the same skills. And so you learn how to do all of this stuff, and it's applicable across multiple places. So I get really excited about this and like to talk about it quite a bit, mainly because if you're newer to these tools, or if you're like, oh, well, I know how to do C#, but I don't know how materials work, or I've never used the universal render pipeline or the XR Interaction Toolkit or anything I'm talking about, Unity Learn has the content you need to show you how to use these different tools. Okay, so there is my in-depth sales pitch on why you should use Unity Learn. Let's jump to, oh, that's it. That's the end of my presentation. Look at that, 30 minutes talking about stuff that I think is really powerful and really cool. I'm assuming that there is some kind of Q&A type format, but I'm sure the production team will let me know if there's not. But otherwise, I would love to connect with you all. If you're interested in things you can connect with for Unity, you can scan this QR code on the left here that says Unity, and that will get you access to a lot of the tools we have available, things we do for students in support of that, access to Learn. And if you want to connect with me and ask, show me projects you're working on or anything like that, you can scan on the right, and that has my LinkedIn and my Twitter, and I believe my email address as well. So thank you all so much for your time, for listening, and letting me tell you all the cool stuff we have going on here at Unity. And yeah, I'll let production tell me if there's actually a Q&A function, and if there is, I'll hang out and talk and answer any questions you might have while we're here.
We thank you so much for your time. Thank you.
Yeah, you're so welcome.
네, 고맙습니다, 여러분.
Thank you. Let's give him a warm round of applause so that he can hear us.